You know, when we picture the ancient Maya, we usually think of those incredible pyramids rising out of the jungle, or their mind-bendingly complex calendars. But what if I told you their most brilliant achievements weren't just what they built, but where they built them? In the middle of a tropical jungle with insane environmental extremes, they came up with engineering solutions that just completely break the mold for what we thought ancient technology could do. So let's dive into how they pulled it off.
Okay, so here's the big mystery we need to solve. A lot of the major Maya cities, like the legendary Tikal, were built on this landscape of porous limestone. And this stuff, it just soaks up rainwater like a sponge. What that means is there's practically no surface water, no rivers, no lakes. So how on earth did they support huge cities? We're talking tens of thousands of people with no obvious source of water. That's the amazing puzzle we're going to unpack.
And their environment was just a world of extremes. You had about 5 months of the year with these torrential downpours that led to massive floods. And then, for the next 5 months, nothing. A bone-dry season that left them with almost no water at all. So for the Maya, survival wasn't just about managing water. It was about mastering this crazy paradox.
So what do you do when faced with a challenge like that? Well, their answer was just ingenious. They didn't go out searching for water, they engineered their entire civilization to catch it. Basically, they decided to transform the very stones of their cities into a massive rainwater harvesting system.
And you really have to appreciate the sheer scale of their thinking here. This wasn't just, a few little cisterns scattered around. The Maya literally coated their gigantic plazas, even the sides of their pyramids, with plaster. Then they angled these surfaces with incredible precision to act like giant funnels, channeling every single drop of rain into a network of man-made reservoirs.
Let's just walk through how this city-sized machine actually worked. Okay, so first, the rain hits all those paved, sloped surfaces. From there, it's guided into this network of canals that crisscross the city. Then, and this is the really sophisticated part, they used dams and sluice gates to control the flow, so they could send the water exactly where they needed it most. And finally, all of that precious runoff ended up in these enormous reservoirs that they carved right out of the earth.
To really get a sense of how massive this operation was, just look at this number. The reservoirs at the city of Tikal alone could hold over 900,000 cubic meters of water. I mean, that is an incredible amount. It's enough to keep a population of up to 80,000 people alive through that entire brutal 5-month dry season.
So, problem solved, right? They had the water. Well, not quite, because this incredible solution created a new and potentially deadly problem. Any large, stagnant pool of water, especially in a hot tropical environment, is going to become a breeding ground for nasty microbes and toxic algae. So collecting the water was a huge feat of engineering, but making it safe to drink, well, that was a matter of life and death.
And this brings us to the next big question. How, 2,000 years ago, did the Maya figure out how to purify drinking water for a whole city? I mean, they didn't have chemicals, they didn't have electricity. They needed a solution that was not only effective, but totally sustainable.
And the answer, it turns out, was hiding in this amazing natural material, zeolite. It's a type of volcanic mineral. And what makes it so special is that on a microscopic level, it's full of tiny pores. These pores create what's essentially a molecular sieve, and it's so fine that it can literally trap harmful microbes, heavy metals, and other toxins, filtering the water that passes through it.
Now, how we know this is a fantastic bit of archaeological detective work. Scientists found huge amounts of zeolite and quartz in the sediment of one of Tikal's main reservoirs. Now, these minerals aren't found anywhere near Tikal. The Maya had to mine them and haul them from a site 35 kilometers away. The evidence was undeniable. The reservoir where they found this stuff was uniquely clean, with no signs of the toxic algal blooms that would have made the water dangerous. This is the oldest known water filtration system in the Americas, and they were using it 2,000 years before similar systems popped up in Europe. Just incredible.
And here's another really elegant touch. The Maya actually cultivated water lilies in the reservoirs. And why would they do that? Well, these beautiful flowers are like a natural purity test. They can only survive and grow in clean, healthy water. So if you saw water lilies floating on the surface, it was a living, breathing sign that your water system was working perfectly.
As amazing as all that was, believe it or not, the Maya had an even more stunning trick up their sleeve. In the city of Palenque, tucked away in the hills, they built something that, for years, experts just didn't think was possible in the ancient world.
To put it simply, they created pressurized water, the kind of thing we use for fountains or modern plumbing. This was technology that everyone thought had been brought to the Americas by the Europeans centuries and centuries later. But it turns out the Maya had already mastered it.
And this is how they did it. What you're looking at is the inside of an ancient aqueduct at Palenque. These underground tunnels were the engine of their pressure system. They were brilliantly designed to channel streams from the hills right down through the city center. The genius here is just how they manipulated simple physics. So water enters the aqueduct at a high elevation. As it flows downhill, the tunnel was engineered to get dramatically smaller, going from about 10 square feet down to just half a square foot. It's the exact same principle as when you put your thumb over the end of a garden hose. That sudden restriction acts like a nozzle, building up a ton of pressure and forcing the water out of a small opening with enough power to create a jet shooting up to 20 feet in the air.
And this probably wasn't just for show. Sure, they could have created spectacular fountains in the city plazas. But even more practically, this could have powered things like indoor toilets or wastewater disposal in the royal palaces. We're talking about sophisticated hydraulic engineering, and they did it all with just stone, gravity, and an absolutely brilliant understanding of physics.
But why? Why go to all this incredible trouble? Well, this quote from Professor Lisa Lucero really gets to the heart of it all. For the Maya, these amazing feats of engineering weren't just about survival. They were about power.
I mean, think about where they built these systems. It is absolutely not a coincidence that the biggest, most impressive reservoirs were always constructed right next to the city's main temples and royal palaces. This was a very clear, very public display of power. In a world defined by that cycle of flood and drought, the king who could provide clean water, well, he wasn't just a ruler. He held the power of life and death. He looked like a master of the natural world.
And this idea was woven directly into their art and their culture. You see kings wearing these incredible, elaborate headdresses decorated with water lilies, that exact same flower that could only grow in the pure water that their engineering provided. It was the ultimate symbol of power, a constant living reminder to everyone that their king was the divine provider of life itself. Now, in the end, even this incredible system had its limits. When faced with mega droughts that lasted for centuries, this civilization eventually collapsed. But their story has never been more relevant. As our own world faces growing water crises, their achievements really leave us with the huge question: what can we learn from these ancient masters of sustainable engineering who managed to build a thriving world in one of the most challenging environments on Earth and keep it going for more than 1,000 years